Okay, guys, good morning. We are going to try to do the live stream. Um, I know that it's the first time we're going to be doing this, but I think if you have any problem, you can always just let me know. Okay, so we are going to be treating physics 2018 today. So just kindly try to follow up. If you are at the center, you try to connect to the Wi-Fi at FIBMAT, and then we are going to see what to do. Okay, so we are going to start right away. I'm in class here in Boya. um, we are going to see what we can be able to, how far we can be able to go today. All right, so we are going to start with question 76 of physics, that's physics 2018. Okay, physics 2018. It says the question reads that two electric charges negative 6 microcoulombs and plus 6 microcoulombs are placed respectively in 2 points A and B, distance of 1 meter apart. The electric field is null at the point C. Okay, at the point C. Now, I'm sure I've explained to you guys before. Okay, I've explained to you guys before that when you have a charge, let's say at points A and B, okay, if the charge at A, let's say, is plus Q, and this one here is what? Plus 3Q, okay? Since these two charges are what? Like charges, where the charge is going to be, where the force or the electrostatic field is going to be zero, okay, is somewhere in between the two because the force is repulsive. So this one is trying to push this one is trying to push this one. So at the end, okay, the force on if you place a test charge here, okay, plus 1 here. So the force due on plus Q due to A, okay, is going to be acting in this direction FA, and the force due to B, okay, is going to be acting in this direction FB. And at the end, if this charge is supposed, if the electrostatic field or the force is supposed to be zero, okay, if it's zero at the particular point here, it means that FA is equal to what? FB, not to. And I also explained that if you have two charges, okay, that are unlike charges, if the two charges are unlike charges, not to. Unlike charges means they are going to be attractive. So if I have negative Q and what? Plus 3Q, for example, okay, the charge is going to be zero, okay, out of the line joining the two, because number one, the two forces are attractive. So if they are attractive, it means that this force, we can never be zero in between the two, right? And so the force is going to be zero out of the line that is joining what? Negative the two points, okay? So the force is going to be zero, or the electrostatic field is going to be zero out of the line. Are we together? And then now it is going to be zero out of the line at the side of the charge with a smaller magnitude. Is it okay? At the side of the charge with a smaller magnitude. That's how it's going to be like. Is it okay? Yes. So in this question, you have been given what? Negative 6Q. So it means that if the charge is supposed to be zero, it's going to be zero somewhere now. Okay, at the same distance, let's say x, okay, from negative, the one with the smaller magnitude, I did not say the one with the negative charge or positive, the one with the smaller magnitude. So here I have negative 6 microcoulombs, okay, that have been given the equation, and plus 6 microcoulombs. Is it okay? Obviously, the charge cannot be. This is point A and this is point B. Now, obviously, the two charges, okay, it cannot be zero, okay? The force cannot be zero in between the two charges, right? Because they are opposite, so it's going to always be attractive. So it is going to be what? Zero out of the line joining the two. We are not going to specify that it's A or B, okay? Because it will happen at the equal distances from A and B. Is it okay? So you will not specify, so it's going to be out of the line joining A and B. Is it okay? Out of the line joining A and B. So the answer there should be Z, right? 77. A generator of electromotive force, 24 volts, supplies a circuit having in series a motor 18 volts and 7.5 ohms in that internal resistance, and an incandescent lamp 3 ohms. The intensity of the current in the circuit is 0.5 amperes. The value of the internal resistance of the generator is, okay, okay, so let's look at it. There's a generator of electromotive of 24 volts, okay. So we're going to say this generator, this is a generator, not so. It has EMF equal to 24 volts, not so. And this is the internal resistance, small r, okay. The supplying current, it supplies a circuit having in series a motor, okay, a motor of EMF of 18 volts EMF, right? So it's supplying this circuit. And internal resistance 7.5 ohms, 18 volts, 7.5 ohms, and what? And an incandescent lamp, right? Let me say you have a lamp like this, okay, and the resistance of the lamp is 3 ohms, okay. So the total current in the circuit, okay, current is going to flow in this direction, okay, the total current in the circuit is 0.5 amperes. So they say the value of the internal resistance of the generator is what? Okay, they're asking for the value of the internal resistance, okay. Now, if we want to look in the circuit, okay, what is the resultant voltage that is going to be played in the circuit? What's the resultant PD?
24 minus
24, okay, because look at something. This, remember I told you the other time that when they say something is supplying, not to. So this one is this one supplying, why this one is what? Receiving. So it means that they are actually connected, is connected in parallel with the generator so that the generator can be able to force current into the circuit. Okay? So it means that in this circuit, alright, the resultant, the effective PD, okay? The effective PD is equal to what? Let's call this one E1, okay, and this one E2. So it will be E1 minus E2 because this one is forcing current to this, not so. Which I'm going to have 24 minus 18, which is equal to 6 volts. Okay? Now, this current in this circuit, okay, the current in this circuit is flowing as a result of what? This 6 volts. Alright? And we know that V is equal to what? IR now. V is equal to IR. Okay, so what's the total resistance in the circuit? Okay, it's going to be what? 7.5 plus 3 plus R, not 2. So it means that R, so it means that 6 is equal to I is 0.5, right? Into R is 7.5 plus 3 plus R, not 2. Implying that 6 is equal to, please do the mathematics. That's 0.5. I'm going to have 0.5 R plus what? 7.5 plus 3 is 10.5 times 0.5. This was 5.25. 5.25. Okay? So it means that 0.5 R is equal to 6 minus 5.25. Implying that R is equal to
1.5.
Sorry?
1.5 ohm.
R is equal to 1.5 ohm. Okay? The internal resistance of the generator is what? R equals to 1.5 ohm. Okay, those of you that are watching from Douala, you can actually share the link. If you can share the link to your other friends and inform them that we are having the class, okay, they can actually be able to join. If this goes on today, well, we might see how to to continue doing it with time. It should be fast. Okay, question 78. An electric motor operating with a voltage of 120 volts provides a mechanical power of 240 watts. This motor, which is caused by a current of 2.5 amperes, has an EMF. Okay? Has an EMF. So they said an electric motor operating with a voltage, so it is operating with a voltage, alright? The voltage that is supplying it is what? 120 volts, okay? So the voltage across this electric motor is 120 volts, okay? And they say it provides a mechanical power of what? 240 watts. Are we there? 240 watts. So power equal to 240 watts. Now, they said this motor, which is caused by a what, current of 2.5 amperes, has an EMF. Okay, so the current that is causing this is equal to 2.5 amperes. Okay, what do we know? We know that the motor, current is being forced into the motor. Are we together? And I said that if you are producing current, okay, the EMF across will be equal to what? V plus IR. Then if current is being forced into you, okay, it means that in the circuit, if current is being forced in the circuit, the EMF of what the current is forced into is rather V minus IR. Are we together? Okay. So I've been given the current in the circuit. We have not been given the internal resistance of the motor. Okay. So it means that actually the V is, so what is the power? The power that is supplied. If we look at the power motor, and then we look at what? We look at the current. Okay, if we look at the power and the current, what is the formula for power? Power is equal to I squared times R now. Okay, we have I squared times R. Power can also be given as what? IV. It can also be given as what? V squared on R. Okay? So if you want to use this other one here, it means our resistance should be equal to what? Power, which is 240 divided by 2.5 squared now. Okay, 2.5 squared. Answer. Right? It's 8.4 ohms. Okay? It's 4.4 ohms. It's 8.4. So mean that the EMF should be equal to what? The voltage, right? That is supplying the motor. That's one. Okay? Are we there? 79. In a parallel plate capacitor, an electric field vector, okay? In a parallel plate capacitor, an electric field vector, A says has a direction perpendicular to the plate. B says has a direction parallel to the plate, and E is directed in the sense of increasing potential, and Z says is directed in a direction parallel to the plate. Okay. Now, how are electric fields directed? Perpendicular to plates. Okay. Because even the parallel plate capacitors, alright, the parallel plates of the capacitors are going to have what? They are going to have there will be a positive plate and a negative plate, right? Okay, because normally you are going to connect them across what? Across a battery. Okay, so the positive terminal is going to be from here. Okay, so the field lines move from positive to what? Negative. Okay, so they are going to move in the direction perpendicular to the plate. Okay? They are going to be moving in the direction perpendicular to the plate. So the electric field lines always move in the direction perpendicular to the plate. So far as you have a positive terminal and a negative terminal. Is it okay? Next question. 80. Calculate the impedance of a coil of resistance 10 ohms and inductance of 59 millihenry supplied by a sinusoidal voltage of frequency 50 Hz. This one is not a difficult question, right? Okay? This one is not a difficult question. So calculate the impedance of a coil of resistance 10 ohms. So resistance is equal to 10 ohms. Okay? Now for us to calculate impedance, remember Z, not to, which is the formula for impedance equals what? Square root of R squared plus what? X XL minus XC all that squared. Okay? Where XL is a what? Inductive reactance and XC is a capacitive reactance. Is it okay? So it means that what? I need to calculate the capacitive reactance, the inductive reactance. Now the capacitive reactance in this circuit is 0. Okay, because it has just what? The inductance and the resistance. Okay, the resistor. So XL is equal to 2 pi FL now. Okay, which will be equal to 2 pi times the frequency, which is 50 Hz, times the inductance, which is 100 millihenry, right? Okay. So 59 millihenry, so 59 times 10 to the negative 3. What's our answer? What's the answer? 18.54 ohms, right? So here will be 18.54 ohms. So since the XC is there's no capacitor in the circuit, will be 0, right? So square equal to. What's the answer? Twenty-one point 21.06 ohms. Okay. So it means the answer is not there, right? The answer is none of the above. Okay? None of the above. None of the above. Okay, next question. 81. It says that the induced EMF in a coil of negligible resistance has a value of what? 4.5 microvolts. Okay? No, it should be, I think it should be 4.5 micro ohms. What is the value of the voltage at the end of this coil? It said the induced EMF in a coil of negligible resistance has a value of what? 4.5 microvolts. Okay? So, what is the value of the voltage at the end of this coil? Of course, it should be 4.5 now. Okay, 4.5. You don't need to solve that one. 82. 314 meters of an isolated copper wire of radius 1 millimeter. Okay, is one in turns around a cylindrical nucleus of diameter 10 centimeters. Okay, of diameter 10 centimeters. So the number of turns of the solenoid is what? So it means that you are supposed to take a bar like this. Okay. Not so. Then you now start, okay, like making the copper wire turns around it. Is it okay? Okay, in this manner. Are we there? So if you have to do that, how many turns can you do? How many turns can you do? Because you are supposed to have, let me say you have 314 meters. Okay? The length is 314 meters. Okay? So, the first thing you ask yourself is, they told that the what? That it is one in turns around a cylindrical nucleus of diameter 10 centimeters. Okay? The diameter of 10 centimeters. Diameter equal to 10 centimeters. Not so for the nucleus that you are supposed to wear it around. Okay? Diameter is 10 centimeters. Alright, you mean that you calculate the what? You calculate the circumference. Okay, calculate the circumference so that you know that okay, one circumference is going to take what? Okay, this amount. Okay? So diameter is equal to 10 centimeters. So it means that the circumference of this nucleus, okay, is going to be equal to what? Why have you calculate circumference? Okay, 2 pi radius now. Or what? Pi diameter. Okay, because 2 times radius is diameter. So yeah, I'm going to have the circumference is, that's z equal to what? That's pi times 10. Okay, which gives me? No, we work with it in centimeters because the length of the. Okay, the length of the copper is also already in meters. Okay, so let's convert it to meters. So if it's 0.1, if you have to convert it to meters, it's 0.1 now. 0.1 meter. Okay, and so I'm going to have, since it's pi diameter, I should have 0.1 pi. Okay, 0.1 pi. What is pi? Sorry? 22 and 7. Okay? 22 and 7. No, 3.1. 3.14 is 0.1 times 3.14. Okay? Which gives us what? 0.314. Okay? 0.314. So the length of the copper wire, that's in meters, right? So the length of the copper wire is what? 314 meters, okay? 314 meters. So what do we do? So 110, not so. 110 is going to give us 110 not so is 110 and that is 0.314 meters. Okay? 110 gives us 0.314 meters. So it means that what? It means that how many turns is going to give us the entire length of the copper wire? Are you guys getting what I'm trying to say? Okay? So it means that 110 not so. 110 1 complete turn is equal to 0.314 meters. Therefore, x turns now should be equal to what? 314. Okay, which is going to give x will be equal to 314 times 1 divided by 0.314, which gives us 1,000. 1,000 turns. Yes.
What about, you don't consider the diameter of the
No. Why are you using the diameter of the copper wire?
I thought the diameter of
The diameter of the copper wire might tell us how close the thing should be packed. Not really
So
the
the
number of
value
turns.
of your circle phase there is in meters, and then that of the distance is in centimeters. Since you have to convert.
What?
I've already converted.
I've already converted.
Yeah, I've already converted.
The second one is in I've already converted. That's why I'm learning 0.314 meters. Okay? Is it clear? Please, here I don't think that the diameter of the what? The radius of the copper is going to count. Is it okay? The radius of the copper I don't think is going to count. Because that's if they are giving us the length. Please, are you following? If they are giving us the length of the nucleus, okay? Please look up. If they are giving us the length of the nucleus, okay, that's when the diameter of the copper wire is going to count. Are we together? Because if you calculate now, okay, the thickness of the copper wire is what? Is 0.1 now. The thickness of the copper wire is 0.1. So if it's you say it's 1 millimeter, right? So how many of those millimeters is going to cover the length instead? So you use the thickness of the copper wire when they give you the length of the nucleus. Okay? But when they give you the diameter of the nucleus, okay, you consider the diameter of the nucleus and then know the number of turns of copper wire that will go through. Okay? Good. So the answer is 1,000 turns. Okay, it's 1,000 turns. Are we together? Can I write? This next question. It is 83. They say a domestic iron 420 volts, 1000 watts functioning without interruption from what? 4 p.m. to 6:30 p.m. consumes electrical energy of what? We have solved that question, right?
Yes, yes.
We know that power is equal to what? Or energy is equal to power times time. Okay? So our time here was what? From 4 o'clock, from 4 p.m. to 6:30 p.m. is 2 hours, 2 hours 30 minutes. Okay? So the total in minutes is 150 minutes, right? And of course it's equal to 150 times 60 equal 60 seconds, which gives us 9,000 seconds. Are we there? So the electrical power is equal to the energy is equal to the power, which is 1,000 watts. Okay? Times what? Times the time, which gives us 9,000. Okay, which is 9.0 times 10 to the 6 joule. 9.0 times 10 to the 6 joule. The answer is what? Is B. 84. 84. If the atomic nucleus emits beta particle, okay, the resultant nucleus will contain. If the atomic nucleus emits beta particle, the resultant nucleus will contain. Now, when you emit a beta particle, right, the atomic number increases by what? The atomic number will increase by 1, and then your atomic number increases by 1, your mass number remains constant because the beta particle is massless, okay? It doesn't have a charge. So if you emit an alpha particle, your mass number will decrease by 4, and your atomic number will decrease by 2, okay? But with the beta particle, the atomic number will rather increase. So they said if the atomic nucleus, now they did not give you the atomic nucleus, right? If the atomic nucleus does not appear, they just know that the atomic number is going to increase by 1, okay? So it was it was thorium 234, okay, 90. Are we there? Thorium 234, 90. So it's going to give us, you see, remain thorium what? 234, 91, okay, plus a beta particle, okay. So if it means the atomic number will increase by 1, the mass number remains constant, okay. Or not necessarily thorium, it can be another nucleus, okay, because the atomic number is something, so you can put X. You can put X in that place. 85. The corpuscular character of light is highlighted by what? Photoelectric effect. Corpuscular character of light means what? The particle character of light. Okay, the particular character of light. So you can demonstrate that light is a particle using the photoelectric effect. It's a photoelectric effect that tells us that light is made up of what? Particles, okay, of energy exists in packets of energy that we call photons. Okay, and the energy of each photon is equal to what? Hf. Okay, E equals to Hf. It tells that it exists in packets of energy, so it's E equals to Hf. Okay. Question number 86. For a given photoemissive cell, which of the following options is correct? A says the outgoing electric current depends on the wavelength of the radiation used. Okay? B says the threshold frequency does not depend on the cathode metal, but on the anode metal. No, because for a photoemissive cell not to, what they do is that, let me say you have a cell like this, right? They make the anode, the cathode, okay? So you have the anode this way, which is positively charged, and then the anode, the cathode is a plate, okay? It's a photoemissive plate. So when incident ray, okay, that's why when incident a particular radiation on the cathode, right? If the energy is what? At least equal to the threshold frequency. At least equal to the threshold, that's the work function of the metal that is used to make up the cathode, right? It's going to what? It's going to emit electrons, not to following what? Answer from electric theory. Meaning that the energy of the radiation which are using should be at least equal to what? The work function of the metal. Okay? So with that, if you incident the ray on this metal surface, that's the cathode, it's going to emit electrons, right? So it means that they say the threshold frequency depends, okay? The threshold frequency will depend on the metal which is used to make the cathode. Okay? Because you need to emit electrons on the metal surface, okay? You need what? You need energy, right? And the energy which will be able to emit any electrons on that metal surface will depend on what? On the kind of metal which is used to make the surface. If it's sodium that was used, it's different. If it was potassium that was used, it is different. If it's zinc that is used, it is different. Okay? If it's that was what was used to make the cathode. Okay? Since the threshold frequency depends on the number of photons reaching the cathode per second. No. Okay? The threshold frequency depends on the metal that is used. This is the intensity of the outgoing current is greater when the cell is lighted by visible light. The visible light has a low energy, right? Okay, so the intensity, okay, the intensity will not be high because a lot of electrons are not going to be emitted. Okay, so please the answer there is, they say for a given photoemissive cell, which of the following is correct? They say A, the outgoing electric current depends on what? The wavelength of the radiation used. Okay. Are we there? 87. What is the mode of disintegration of a cathode 14 nucleus? Carbon 14 nucleus.
So you say answer for number
86 is A. Okay. Why is it beta emission? Now you usually use the what we call the neutron to what? Proton ratio, okay, to know whether it's going to be alpha emission or beta emission. Is it okay? If neutrons are greater than what? If neutrons are greater than protons, okay, it means that a neutron is going to be converted into a proton and an electron and a beta particle. Is it clear? So it means that you look at your neutron to what? Proton ratio. Okay? If neutron to proton ratio is greater than 1, okay, it means that we are going to undergo what? A beta emission. Okay? If it is less than 1, then we are going to undergo alpha emission. Okay? So, like here in this nucleus, okay, we take carbon 14. In the carbon 14 nucleus, how many protons does it have? It has six protons, right? So it has 6 protons. How many neutrons? 8 neutrons. Okay? It has 8 neutrons, so 8 plus 6 will give us 14 as mass number. So neutron equals 8. Okay, so you see that the neutron to proton ratio is what? That's the reason why a neutron, okay, will be converted into what? A proton. Are we together? Plus what? Plus a high energy electron, which is called a beta particle. Okay, 0, negative 1.
Sorry.
Oh, sorry.
Come and check your list.
Okay, there is something here. Okay, so a neutron is going to be converted to what? A proton and a beta particle, not so. So the neutron has a mass of 1 and what? A charge of 0. Are we together? So you see that it's going to emit what? It's going to produce a proton. This proton will stay in the nucleus. Are we there? Because the problem is here is what equalize the neutrons and the protons. Okay. So what it does is that you convert a neutron particle into a proton and a high energy electron that we call a beta particle. Okay. So that and then the beta particle will be emitted while the proton is going to stay in the nucleus. So when your neutron to proton ratio is greater than 1, you have what? An alpha. Sorry, you have a beta emission. If it is less than 1, you have alpha emission. Is it clear?
What about for gamma?
No, gamma is just to stabilize the molecule. Okay, for gamma emission is just to stabilize the gamma emission is just to stabilize the nucleus. Okay, because when they emit particles like that, they are now occupying what? High energy levels and they are unstable. So for them to become stable, what do they do? They emit some amount of energy, okay, to go back to their ground state. Okay, to become stable.
When the neutron number is greater than 1, is it more stable or more?
Neutron to proton.
Yes, when the ratio is greater than 1.
No, when it's greater than 1, it's unstable. That's the reason why there is disintegration. If it's less than 1, it is still unstable. So it only becomes stable when it's approximately equal to 1. Okay, so the more closer you are to 1, the more stable you are. Okay? I can wait now. Okay. Okay? Which question are we? So the answer there is 87 is 80, right? 89. 88, sorry. What are the values in nanometer of the wavelength limiting the visible part of the electromagnetic spectrum? Okay, we have discussed it further is what? 400 to 750. Is it okay? 400 to 750. But if you don't have, in this option here, you don't have 400, right? You have 400 to 800, yes. Which other one do you have? 380 to 750. Okay, I think that you can take that one.
We have 385 to 7.
No. Normally, its average is what? 400 to 750 nanometers. Okay, so you can take 3.8 to 750. Normally, it is 400 to 750. Okay. 89. The radioactivity of an element is influenced by the binding energy per nucleon. Okay. The binding energy per nucleon. That's what influences radioactivity. Okay, because it is, remember there's a question that we always answer that radioactivity is what? Is linked to the structure of the nucleus. Is it okay? It has nothing to do with the chemical structure of the element. Okay? It has nothing because the chemical structure of the element is determined by the electrons. Okay? So it has nothing to do with that. It has nothing to do with electronegativity. It has nothing to do with the Avogadro's number. It has something to do with the nuclear structure. Okay. So it's binding energy per nucleon. 90, which is not an SI unit. Okay, Zalon, are we there? You choose that one. Will answer me? 91, the origin of Laplace's force is what? Electromagnetic. I already showed you that Laplace's force is what? F equal to VIL sin theta. Okay? But now for Laplace's force, it's usually directed perpendicular to the magnetic field. That's when theta is equal to what? 90 degrees. Okay, and so F equal to VIL. See, sin theta, sin 90 is what? 1. Okay? Then there's the other one, Lorentz force. Okay, Lorentz force is F equal to V cube V sin theta. Okay? Now it is this Lorentz force that tells us that what? This V here is speed. Okay? It's the speed of the electron. You can replace Q here with E when it is an electron. Okay? So this Lorentz force, okay, helps us know that what? We cannot, an electron does not generate an electric field when it is what? When it is stationary. Because when it is stationary, it means that V is equal to what? 0, and so force will be equal to 0 automatically. Okay? So when an electron is on one position, it generates what? An electric field. If it is moving, it generates both an electric field and a magnetic field. Okay? Are we there? 92. In a vacuum and in the same region. We have seen this question before, right? In a vacuum and in the same region. Okay, all bodies fall in the same manner. Okay, all bodies fall in the same manner. In a vacuum and in the same region, all bodies fall in the same manner. Okay, please, my device is a bit low, so I will suspend the live stream for now, and then I will continue. Let me charge the stuff again. I will continue back with that. Okay. I'm not talking to you.
You cannot answer, so
Please permit me just suspend the live stream for now. Let me charge my device. Okay, it's a little bit low. Then I'll continue from where I actually ended. Okay.